Grace Fletcher.
I'm Grace Basinger.
And this is our final presentation for our Streamflow project. Part 1, we started building our data models for forecasting flow rates.
For the linear regression model, we began by importing all the necessary packages. Then we read the CSV file and dropped the date, delta, saturation index, and evapotranspiration, and flow columns. So we only had to look at the precipitation, Tmin, Taverage, Tmax, and flow rate. And since we only had to look at the data for the first 5 rows, we created a new subset for the new data and printed its information.
We then displayed the descriptive information of the data in terms of the average number within the values, as well as printed the info for the first, second, and third quartile. After that, we were able to print the pair plot values to better see the relationship between the independent and dependent variables. After that, we displayed a histogram of the subset of the data, and then we printed a heat map of the data which displayed the correlation between the parameters.
Then we imported sklearn model selection to split up the data into 75% for training and 25% for testing. After that, we standardized the information in order to make a standard range for the data to function properly using the standard scalar and pipeline methods.
After that, we formed the linear regression model by importing the linear regression function from sklearn, as well as metrics and cross-val score. We created 3 functions: the cross-val, which calculated the mean, the print evaluate, which calculated the mean absolute error, mean squared error, root mean squared error, and r-squared error. Then we fit the linear regression model and found the intercept of the linear regression line and printed the coefficients of each parameter.
Then we printed a prediction for the linear regression using the x test value and printed the test set and train set evaluations, which included the MAE, MSE, RMSE, and R2 squared values.
After this, we created a cell for user input so they could input values of precipitation, minimum temperature, maximum temperature, and average temperature to calculate the forecasted flow rate.
Next, we began separating the parameters into x and y values for training and testing the values. So we imported the necessary packages for this task and began the logistic regression model. By using the example in the textbook, we were able to build this model and have it print the linear regression intercept as well as the coefficient of PPT, Tmin, Taverage, and Tmax. And by doing this, we are now able to make predictions for the logistic regression.
Our last model that we created was the power law model. We started by importing all the necessary packages and declared the x and y values and plotted a graph of the relationships between. The next step was to append a new logarithmic column to the data frame that was calculated from the y values.
After the new subset of the data frame was created, we initialized a fit a linear regression model using stats models. The new values were predicted using model predict and using the beta, SSE, and RSQ values. These results were then plotted. We printed the beta 0 and beta 1 values and created a new flow rate function.
The second part of our model building was forecasting flow states. Now that we were able to make 3 models for the first part of the project, we created 3 more models for the flow state part and made some adjustments. For all the models, the only parameters that were needed were the precipitation, minimum temperature, average temperature, and max temperature. Since we were using these to predict flow states, we didn't need the flow rate parameter anymore. Here is our multiple linear regression model for the forecasting flow states. And here is our logistic regression model. And then our last model was the power law model for forecasting flow states. After creating and implementing our models, we realized that the multiple linear regression model was the best fit for both parts of our project.
Some of the challenges we faced during this project was a logistic regression model. We had to adjust the values from float to integers since logistic regression is used primarily for classification. And since all the values have been continuous in order for the program to run, we use the label encoder function out of the sklearn to convert the continuous values to categorical values. If you see here, we have shown how we split up the project into pieces equally. For the literature research project, we divided the bullet points and decided that Mary Grace would cover the first bullet point and I would cover the second bullet point. We had done our research and put it on the same file and read each other's work and made adjustments and transitions as needed.
As for the EDA assignment, we took on a similar tactic. We split the first 4 bullet points to where I did the first 2 and Grace did the second 2. Then I took on the 5th and 6th bullet points while Grace completed the last bullet point. We had gotten together to create the code to give us the information we needed to decipher and to answer the questions. And as we had before, we both put our work onto the same document and corrected and changed any errors or corrections we needed.
Then, for the model building part 1 and 2, we chose that Mary Grace would do part 1 and I would do part 2. We decided to collaborate and write the code together to make sure we were on the right track. We both helped each other in building the 3 data models for predicting the flow state, as well as the different algorithms to find goodness of fit measures.
So, in working together, we have been able to complete this assignment by doing our own research and working together to write the necessary code for this assignment and bring it back into the same assignment.